Hello, everyone. Happy Friday. Y'all made it to the end of the week. If you could do me a favor and turn on your video so I can see your beautiful faces. And then we'll get started on our do now. All right. What's your favorite Beyonce song? Write your answer in the chat. And what conditions must be true in order to add and subtract radicals? So there's things that need to be the same in order to add and subtract radicals. And if you just got in, make sure to turn on your video. Looking at you, Liana, Nancy, and Karen, and Sandra. Karen, you don't like Beyonce? What is wrong with you? How rude.
How rude. I don't know. Just no.
Right. I just don't listen to that. I don't.
Yeah, not only is it not my music taste, but like she might be a little overhyped.
Get out of here. I'm going to mute you.
Yeah.
Wow, period 10 does not like Beyonce. Ethan, I get into this debate all the time. People always argue with me that Rihanna and Alicia Keys are better. And I love them too, but it's tough. It's tough. I guess Hannah's the only one on my side here. That's fine.
I hope you don't think she's like a god. This is the school of Beyonce, the church of Beyonce.
Yes, that is what my problem is. People like put her on like a higher pedestal, and that's when they tax it, and I'm like, please stop.
I don't think that I don't put her on a pedestal.
Though. She got a whole bunch of songs with Kendrick and A$AP Rocky.
Listen, I love Rihanna too. I think she's got some really good stuff too. But I think that Beyonce's like visual stuff is unparalleled. Like her visual albums.
Nah.
Yes, all her visual albums do smack in every way.
Yes.
I haven't given her a chance. I'm not planning to either. It's not my music taste, not my scene. I'd rather just stick to my MJ, Harry Styles, all that good jazz.
This is my last thing I'll say about Beyonce. I feel like every time she's
that
like
lotion is nice. I can't lie.
What'd you say, Ethan?
The Fenty skin lotion is nice. I can't even lie.
The Fenty skin lotion is nice. I have not tried.
Yes, her makeup.
Yeah, bro, it's nice. When you wash your face, when you get that nice tingle, if it's not tingling, it's not working.
Oh, you guys kill me. I think there are benefits to each one. I think Alicia, Rihanna, and Beyonce all have their pros. And I think that our next do now question will be to make a pro-con list for each of these female artists. I think that's what we'll have to do. So everyone prepare that over the weekend. That will be in addition to your regular homework, and we'll discuss on Monday. All right. Now let's get to the math part of today. What conditions must be true in order to add and subtract radicals? So what needs to be the same for you to be able to add and subtract? What do you have for me, Sandra?
They have to have the same index and same radical.
You have to have the same index and the same radicand. So the number underneath the radical has to be the same. Any questions about that? Okay, does anyone, almost forgot good things. How could I forget good things? All right, today's good things are coming from, let's do Liana, Nancy, and Sandra.
The good thing for me is my mom being out of town. She comes back tomorrow.
Yay, that's exciting. Where was she?
She was in South Bend.
Gotcha. Cool. Thanks for sharing. And then Nancy, what's your good thing?
I don't know. I don't have anything good to share.
Out of all the things that happened today, what was the best thing?
I don't know. I really don't know. I get to go to work, I guess.
Okay, that's a good thing. Yeah, for sure. Thanks for sharing. Sandra, what's your good thing?
I only have one homework left.
You don't have much homework today? Woohoo! That means you're gonna have a great weekend. All right. My good thing is today's Pizza Friday, obviously, but also it's pajama day, so I wore my pajamas to school. What a party! And then also, look at this cool bucket hat I got for free at lunch. It's a North Central bucket hat. So I'm just living my life today. My wardrobe. I'm never taking this bucket hat off. It's staying the entire weekend.
Bucket hats.
What about bucket
hats? Are some of the most underrated hats. I have so many.
How many do you have, Ethan?
I got like 4 or 5.
Okay, because
I
I
got one from North Carolina. I got one with palm trees on it. I have one from my middle school.
right on. I'm at this makes
Which
me
looks
at
like
5
cut
right now.
out.
Leon, are you taking a picture? I'm at 5 too, Ethan. This will make the 5th one. All right. Any questions about last night's homework before we get started on the new stuff? Okay, no questions? Sure? Positive? Double positive? Oh, also, guys, today's Friday and I'm in a mood, but I got a funny joke that I learned today and I'm gonna share it with you all. What's a math teacher's favorite place to visit? Times Square. Get it?
Oh, yeah.
Oh man, I cracked myself up. Okay, let's get started with some math.
That was kind of funny, but it was kind of lame at the same time.
Thank you for your honesty, Nancy. Appreciate it. All right. Woo, let's go. Exponent rules. This should be a review from Algebra 1. And yeah, so it shouldn't be anything new. We're taking a pause from radicals for a moment and we're going to move to exponents. So we're just going to take today to review some Algebra 1 stuff. So the first thing we're going to do is add and subtract monomials. So those are just terms that have one term in it. So that's just combining like terms. So don't try to change the variables. Don't try to change the exponents. Just combine the coefficients and keep the variables and the exponents. So for example, for number 1, you've got 9x squared y minus 10x squared y. Make sure that you have like terms. So you have the x squared and you have the y, and that matches up. And then once you know that it matches, you can just subtract the coefficient. So 9 minus 10 is -1, but you don't need to include the -1. The negative is fine. And then keep the variables and exponents. So keep the x squared y. All right, number 2, subtract 6w from 8w. So let's convert that to an equation. So it's going to be 8w minus 6w. Double check that you have the same terms, so like terms. You have a w and a w. The exponents match. So then you can just subtract the coefficients. 8 minus 6 is 2. Keep the variable. Questions? All right. The first rule we're going to talk about is product rule, and product means multiplication. So anytime you multiply two terms with the same base, so in this case the base is x, then you end up adding their exponents. So you're just going to keep the base as x and then add a plus b. So example 1, we've got h squared times h to the 6th. So keep the base as h and add the exponent. So 2 plus 6 is equal to 8. All right, let's try a little bit more of a complicated example. So for number 2, we've got numbers. We've got the -2 and the 7, and we've got two different variables. We got the a and the b. So you want to treat each part separately. So we're going to do the numbers first. For the numbers, you just multiply them as is. So -2 times 7. Then we're going to focus on the a. So keep the a and add the exponent. So 2 plus 3. And then you're going to do the b's. You'll notice that the b doesn't have an exponent. If you don't see an exponent, you know the exponent is 1. So it's going to be 1 plus 1. And then just simplify that. So -2 times 7 is -14. 2 plus 3 is 5. 1 plus 1 is 2. So you've got -14. Ooh, you can't see that. A to the 5th, b squared. Questions? All right, the next rule is called power rule. And you know it's power rule because you'll see parentheses around your base, and then it's going to be raised to another power. So it's parentheses raised to another power. And when you have this, you keep the base, so the base is x, and then you multiply the exponent, so a times b. So for number 1, we've got x squared raised to the power of 3. So you keep the base as x, and then you multiply 2 times 3, which gives you 6. So it's x to the 6. All right, let's try a different example, a little bit more complicated. So a couple things here. We've got a number now that we have to raise to a power, and also you have power rule, so you have the parentheses with an exponent, and you have multiplication, so you need to do both of those. So how do you figure out which one to do first? You always want to follow order of operations, so PEMDAS. So do exponents before you do multiplication. Exponents before multiplication. So we're going to do this power rule first. So you take the -2 and raise it to the power of 2. Anytime you have a coefficient, you want to make sure you raise it to the power. And then you're going to do the n. Power raised to a power, multiply those exponents. So 5 times 2. Times n cubed, times n cubed. -2 squared gives us +4. 5 times 2 gives us 10 times n cubed. All right, so then you've got the coefficient 4, so you just keep that, and you're multiplying n to the 10th times n to the 3rd. So remember, anytime you multiply two terms with the same base, you add the exponent. So 10 plus 3 is 13. Any questions on that? All right, quotient rule is next. So quotient means divide. So anytime you have two terms that have the same base, anytime they're divided, you're going to keep the base and subtract the exponent. So it's going to be x to the a minus b. So for number 1, we've got the coefficients 27 and 42. So first you want to simplify the coefficients. So see what number goes into 27 and into 42. And the biggest number that would go into both of those is 3. So 27 divided by 3 is 9. 42 divided by 3 is 14. And now we have to deal with the variables. So you've got x to the 5th over x. If you don't see an exponent, you know the exponent is 1. And because they're divided, I need to subtract the exponent. So it's 5 minus 1. Five minus 1 is 4, so it's 9x to the 4th over 14. Any questions so far? All right, the next example, example 2, we've got y squared to the power of 2 over y to the 4th. So you've got exponents and you've got division. Which should I do first? Should I do the exponents first or should I do the division? I'm going to go ahead and call on someone to help me out. What do you think, Ethan?
One more time.
Should I do the exponents first or should I do the division?
The exponents.
You want to do power rule first. So I want to do y squared to the power of 2. What am I going to do with those two exponents? What am I going to do with the 2 and the 2? What do you think, Nancy?
The 2 and the 2.
What do you do with them, sorry? You add them, subtract them, multiply them.
What 2 and 2 are we looking at? Oh, wait. Yeah, which ones are we looking at?
These guys.
Oh, you multiply them.
Yep, because it's power rule. So it's 2 times 2, which is 4 over y to the 4th. So a couple things you could do right here. You could notice that these are the exact same term. Y to the 4th over y to the 4th is the exact same term. So you could cancel those out. Anything divided by itself is just 1. So you could already say, wait a second, those are the same, so they cancel out and it equals 1. Or you could do quotient rule and subtract 4 minus 4, which gives you 0. And you might be wondering, okay, what does the exponent 0 mean? Anything raised to the power of 0 is 1. And that's what we're going to talk about at the 0 exponent rule. Anything raised to the power of 0 is just 1. So you could have stopped here and noticed that you have the same thing in the numerator and the denominator, which gives you 1. Or you could have finished out the problem and realized that anything raised to the power of 0 is 1. Questions about that? All right, the next one, negative exponent rule. We've got x to the negative a, but we're not allowed to have a negative exponent. So the way we deal with that is you flip it so that x now goes to the denominator. So you can assume that there's an invisible 1. You can make this a fraction. So then you flip it so that 1 goes at the top, x goes at the bottom, and that negative a changes to a positive a. And that gets rid of your negative exponent. If your exponent is in, or if your variable is in the denominator and it has a negative exponent, then when you flip it, you're going to flip it to the numerator. So just switch the order. If it's in the numerator, flip it to the denominator. If it's in the denominator, flip it to the numerator. So for number 1, we've got negative 5, x to the negative 2. We consider these two separate things. So the negative 5 gets to stay at the top, but the x has to go to the denominator. And that negative 2 is going to change to a positive 2. Questions on number 1? Number 2, we've got 4k squared divided by 8k to the 5th. So you have quotient rule again. So first you're going to deal with the not the exponent, sorry, the coefficient. So 4 over 8. So think about a number that goes into 4 and into 8. And the biggest number that goes into both of those is 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. And we need to subtract the exponents because we're using quotient rule. So we're going to do 2 minus 5. 2 minus 5 is negative 3. So you've got 1k to the negative 3 over 2. But remember, you cannot have a negative exponent. So you need to send that k down to the denominator and change that negative to a positive. So it's 1 over 2k cubed. All right, the last one, the 0 exponent rule. So like we said earlier, anything raised to the power of 0 is just 1. So it could be a to the 0, b to the 0, z to the 0. Anything raised to the power of 0 is 1. Number 1, we've got a coefficient, 7 times x to the 0. So keep the 7. X to the 0 is just 1. So instead of 7x to the 0, it's going to be 7 times 1, which is just 7. And then the last one, number 2, w to the 4th raised to the power of 2 over 8. We've got power rule and we've got quotient rule. Do the exponent first. So you're going to do the 4 times 2, do the power rule first. 4 times 2 gives you 8. So w to the 8th over w to the 8th. And then you're going to do quotient rule. So you're going to subtract 8 minus 8. 8 minus 8 is 0. So you've got w to the 0 equals 1. Anything raised to the power of 0 is just 1. Any questions? All right, that is it for the notes for today. I'm going to go ahead and take a moment to show you your homework, and then we'll be done. Does anyone need more time to look at this before I switch the screen? All right, today's homework will be on Canvas. So if you go to your modules, and you scroll down to today's date, which is August 28th, your homework is, nope, it would be helpful if I went to the right class, right? All right, so let's try this again. So go to modules, scroll down till you get to today's date. Your homework is right here, properties of exponents worksheet. So click that. Here is the worksheet that you're going to download. So you're going to click that and you're going to download it. And it's going to look like this. And you can print this out and solve the problems on your worksheet. Or if you don't have a printer, you can just use a blank old piece of paper and do the problems on that. Either way, I need you to take a picture of it and then upload it onto Canvas to submit your assignment. Are there any questions about using Canvas to do your worksheet? Okay, so then your homework tonight is 2 things. You've got your Big Ideas Math assignment, which is 5.2 part 2, and that's going to be due tonight at 11:59, and then you have the worksheet, which is going to be due on Canvas on Monday at 11:59. So you got 20 minutes. I'm going to stick around. So if you want to be super responsible and get your homework done before you leave today, guess someone didn't want to get their homework done. I'm going to stick around until 2:40. But if you would like to leave, have a great weekend. I will see you on Monday.